Oh, let's do some math. All right, today we're going to talk about similar triangles and how to tell if triangles are similar or not. Right? Different than congruent. Congruent was last week. So when we show similarity in triangles, we actually have three ways to prove. And so these are going to look kind of like what we did last week. We have angle, angle, right? That's different than last week. This will prove similarity. We have side, angle, side. So it's similar to last week, but we're going to talk about how the S's don't mean the exact same thing they meant last week. And then we also have side, side, side. Those are the only three ways that you need to prove similarity. We could do like angle, angle, side. But if you think about it, angle, angle already has the two angles taken care of. So why do the extra work and find that side, right? We can just use any of these three combinations. Now, what's a little bit different is that the S's don't mean that the sides are congruent anymore. Because we know that when we have similar shapes, right, when we dilate something, the side lengths are going to change. So they will not be the same measure. What they will be, however, is proportional. So every pair of sides will be in the same proportion. Different sizes, but proportional. Or we can think of that as meaning they'll all have the same scale factor. Angles still does mean that they are congruent. So just like last week, the angles need to be the same, but the sides are going to be proportional. So we're going to take a look at each of the three different ways we can prove. The first one is angle, angle, right, which we usually just refer to as AA. Anytime we have two angles of one triangle that are congruent to two angles of another triangle, then we know that the triangles are automatically similar. Because if they have the same angles, I promise you 100% the sides will be proportionate. It'll just happen, always. So in this example, we know that this angle is the same as angle D. We know that angle C is the same as angle F. And that's enough because if I put numbers on here, if I call this 60 degrees, and I call this 40 degrees, and I know those aren't accurate, but just bear with me. That would mean that this one is also 60 degrees, and this one is also 40 degrees. Well, if we know those are 60 and 40, we can use the triangle sum theorem to do 180 minus 60 minus 40, and we actually know that this angle up here has to be 80 degrees, which means same thing over here, subtract 60 and 40. This angle up here also has to be 80 degrees. So as long as we know two of the angles, we don't even need the third because the third pair will have to be congruent in order to add up to a full 180. So long story short, as long as we have two angles that are congruent to two angles in the other triangle, we will have similar triangles. Now when we write a similarity statement, it's similar to congruent, but there's no equal sign underneath, right? We don't put an equal because they're not equal. The angles are equal, but the actual shapes are not, right? Because we know that the sides are going to be different. The sides will be proportionate. So we just put the little tilde or the little squiggly to mean similar, but we do still need to match up the correct angles with their corresponding angles, right? So angle A and angle D go together. So they're in the same location. Angle C needs to go with angle F. So in this case, they were both written last, which means that last angle, angle B and angle E, they will also share the same location when we write our similarity statement. So order still matters. All right, are these triangles similar? And we're working on angle, angle right now, right? So if I look at it, I'm like, okay, I've got 90 degrees. I've got 90 degrees. That's a pair of angles. But then I've got 30 degrees and 60 degrees. Those are different. But before I say no, I can use the triangle sum theorem and do 180 minus 30 minus 90 to get that this angle is 60 degrees. So do I now actually have a second pair of congruent angles? I sure do. And if I wanted to, I could do the triangle sum theorem here and get 30 and go, oh yeah, those are the same, right? But I don't need to. Once we know two pairs of angles, we know all three will be the same. So we can say, yes, these are similar by angle, angle. When we write the similarity statement, I'm going to name my first triangle. So let's keep it simple, call it ABC. Similar, right? Not congruent, similar. And then we need to make sure we match up the second triangle in the same order. So, how should I name this triangle to make sure I show that they are similar? That's right, I know that angle A was 30 degrees, and that goes with angle X, which was also 30 degrees. So if A goes first here, X needs to go first over here. B is my 60-degree angle, that goes with Z. So if B is second, Z will go second. And then C was the right angle, which goes with angle Y. So similarity statement, we need to make sure they're in the correct order. Now, we don't have anything about the sides on here, right? We just used angles. But what do we know about the corresponding sides of these triangles? Even though we don't have any measures, we know because these triangles are similar, we know that the sides must be proportional. Or, based on what we've done in class prior to this, we know that the sides will have the same scale factor. They will be proportional. Okay, the second way that we can prove similarity is through side angle side. But we said the sides will not necessarily be congruent, they need to be proportional. And we'll show how to figure that out in a minute. And then they do need the angle that's sandwiched in between the two sides, and the angles do need to be congruent, right? Angles are the same, sides are proportionate. So if I look at these two examples, I can see that angle A is congruent to angle D, all right? So I have the A part of side angle side. And then if I want to find the sides, I need to determine, are these two sides proportionate to these two sides? So one way we can do that is through scale factor. So if I go to the shorter of the two sides, from this triangle it has a length of 5. And if I find that same side over here, the corresponding side, it has a length of 3. If I do 5 divided by 3, I get 1.67. So my scale factor to go from 3 to 5 is 1.67. Now I can check to see if this pair of sides has the same scale factor. So if I take my new side, which is 10, divided by the original, which is 6, I get 1.67. What do we notice about both of those ratios? They are the same, which means we do have the same scale factor, and therefore we can say that we have side, angle, side. Now, you might also notice a couple of shortcuts we could use. You might have noticed that if we did 3 times 2, we get 6. And if we do 5 times 2, we get 10. We might notice that pattern. And if that's true, then they will be proportionate. Or we could even go a step further and write a proportion, which we're going to start doing a lot more when we're solving these problems. But I could do something like longer of the, 5 over 3, right, because those go together, and set that equal to 10 over 6, because those sides also go together. And if I cross multiply, I get 30 equals 5 times 6, 30. So if you set up two fractions or two ratios and you cross multiply, if you get the same product, those are proportionate. So I know I'm going over a couple different ways. For today, I'm going to stick to the scale factor idea, but once we start actually finding missing side lengths, we'll probably do more proportions. We're so similar. That's cute. In fact, let's see if these triangles are similar. So first thing I notice that this angle is the same measure as this angle. so they do have an angle. And then I notice the two sides that sandwich it are 15 and 21, and over here we have 5 and 7. So if I take the shorter side of each one, right, 5 and 15, if I find their scale factor, to go from the bigger one to the smaller one, that's a reduction, so it should be less than 1, and in fact it's 0.33. And then if I go from, if I take these two sides, I take the new side of 7, and I take the original side of 21, hey, look at that, the scale factor there is also 0.33. So these sides and these sides are proportionate, and the angle in between is congruent. So they are in fact similar by side, angle, side. Aren't they cute? Okay, moving on. Oh boy, all right. So are these triangles similar? Well, we have one angle, right? We have the 90 degrees. They are congruent, that is good. And then we need to see if the sides are proportionate. So I'm going to take this side right here, 9, and I'm going to compare it to its corresponding side, 6. And if I divide those, I get 1.5. So the scale factor is 1.5. And then I'm going to do the same thing. I'm going to take my new length here of 7.5, divide it by my original side length of 5. And if I divide those, I get 1.5. So are they the same scale factor? Yes, which means we can use those sides as part of our reason. We knew the angle in between was congruent. So yes, these triangles are similar by side, angle, side. Now when we go to write our similarity statement, I need to make sure that I put the angles in the same order, or the correct order. So if I call my first one triangle ABC, how should I match up my second triangle? Well, angle A is this vertical piece and the hypotenuse where they come together. So over here, the vertical piece and the hypotenuse come together at Z. Angle B is my other acute angle that's not the right angle, right? So where my blue side and my hypotenuse came together. So blue side and hypotenuse came together at X. So X should go next. And then C was my right angle. So that corresponds with this right angle, which was angle Y. So we want to make sure we match up the angles that are congruent in the same spots. All right, our final way for proving similarity is side, side, side. So we don't know any of the angles. If we don't know any of the angles, our only option is side, side, side. But now the sides don't have to be congruent, right? They need to be proportionate or have the same scale factor. So the way I do this is I find my longest side of my new triangle, and I set that up with my longest side of the original triangle. So 36 was the longest side of the new, 24 was the longest side of the original, and if I divide those, I get 1.5. So that's one pair of sides. But now we need to make sure that the other sides have the same scale factor. So I'm going to then choose my second longest side, which would be 33. And which side would match up with 33? Well, we need to find the second longest side, so that would be 22. I know that those go together. Divide that, I get 1.5. So far we do have both pairs of sides have the same scale factor. But if we're going to use side, 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 we need to also identify if the last pair of sides is also in the same scale factor or proportionate. So I can take 24, divide that by my original, which was 16, and I get 1.5. So each of the three sides shares the same scale factor, which means they are all then proportionate, which means even though we don't know the angle measures, we have enough information that we know the angles will end up being congruent to each other. So side, side, side is our third and final way to prove that triangles are similar. Okay, so let's look at this example. Are these triangles similar? Well, I'm going to do the same thing with the scale factor. I'm going to take my longest side of my new one and compare it to the longest side of the original. I'm going to need a calculator for this one. 49 divided by 28. 1.75. Now I'm going to take the medium side, and you could go in different orders. You could do the small sides first, then the large sides, and then the medium. But as long as you match up each side with its correct corresponding side. So medium and medium. 35 divided by 20, which is 1.75. So those have the same scale factor. And then finally, I've got 24.5 over 14. Shocker, 1.75. So all three pairs of sides have the same scale factor. So yes, they are similar by side, side, side. And all it would take would be one of these to be different. So if this was 1.75, this was 1.75, and this was 1.4, then they wouldn't be similar. You only need one pair that's not similar or not in the same scale factor to make them not similar triangles. But these ones were similar. So if I write my first statement as triangle ABC, I need to match up the similarity statement with the corresponding parts. And although I don't have angle measures, which makes it a little bit easier, I can look to see that angle A was my side that was sandwiched between the green and the red. So I just go over here, green and the red was angle D. And then angle B was between the green and the blue. Right, green and the blue was E. And sometimes they'll actually like rotate the shape, so it's not as easy as this one. You might have to actually look a little bit closer. But then C is our last one, so that goes with F. So triangle ABC is similar to triangle DEF. All right, so we've got three ways to prove similarity. Angle, angle, side, angle, side, 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 side. Angles must be congruent, but sides need to be proportionate or in the same scale factor. So now I'm just going to give a couple problems. I'm not saying which one we're trying to use, which of those reasons. We need to look at the picture and figure out which of those three can we use to determine if they are similar or not. So when I look at this one, I notice I don't have any side lengths. So again, my options, I have angle, angle, side, angle, side, 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 side. Well, if I don't have any side lengths, can I use side, side, side? No. If I don't have any side lengths, can I use side, angle, side? No. So my only option is going to be angle, angle. And when I look at it, I know I have 90 degrees, 90 degrees. Initially, these are not the same, so I don't have enough information to prove. But if I use the triangle sum theorem, I can get that this angle is 55 degrees and this angle is 35 degrees. So do we in fact have a second angle that matches up? Why, yes, of course we do. I've got 35 degrees and 35 degrees, or I could use the 55 and the 55, but we definitely have enough to say that those are similar by angle, angle. So again, angles will be the same, sides will be proportional. Okay, this next one, angle, angle, side, angle, side, 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 side. Well, how many pairs of sides do I have? I've got this shorter side goes with this shorter side, and I've got this longer side goes with this longer side. So that's two pairs of sides. So I can't use side, side, side because I don't have three. Now angle, angle, I only know one angle. Which angle on this do I actually know? Right? I know that this angle in the middle is congruent to this angle here. So angle ABE is congruent to angle DBE because they are vertical. So I only know one pair of angles, so I can't use angle because I need two pairs of angles. So my only option is going to be side angle side. But before I can say it's side angle side, what do I have to prove about the sides? I need to prove they are proportional. So if I take the longer side of my second triangle and divide it by the original side that corresponds with it, I get 24 over 36, which if I'm doing my math correct is 0.67. If I take the two green sides and I do 18 over 27, and whichever triangle you start with, so since I put 24 on top, I have to use the side from that triangle on top on the next one. I have to keep them in the same order. But anyway, 18 over 27 is also 0.67. So can we say that those sides are proportionate? Well, based on the scale factor, absolutely. And we know the angle in between was congruent because of vertical angles. So yes, these are similar by side angle side. All right, last two examples. Do I have any angles in this problem? I don't. So can I use angle? Nope. If I have no angles, can I use side angle side? Nope. So my only option is going to be side, side, side. So I need to now match up my longest sides, my medium sides, and my shortest sides. So if I go, let's go longest, 14 over 84. And notice it wasn't right side, right? I had to match up the longest side with the longest side. And then I'm going to do the same thing with the medium sides. So 12 and 72. And then I'm going to do the same thing with the shortest sides, 8 over 48. And I'm going to divide those to see if I get the same scale factor for each one. But on a side note, actually I'll do the side note in a second. So if I divide those, 14 divided by 84, 0.167. Repeating, 12 divided by 72, 0.167. And if I divide 8 by 48, I get 0.167. So since all the scale factors are the same, those sides are all proportionate. So we can definitely use side, side, side. Now, the one thing I was about to mention a minute ago, you don't have to go from the right triangle to the left triangle, right? How I put 14, 12, and 8 all on top. You could do the reverse. You could do 84 over 14, 72 over 12, and 48 over 8. And then all of these would actually have a scale factor of 6, right? Either way, doesn't matter. If I'm going from here to here, my scale factor should be less than 1 because it's getting smaller. If I went from this one to this one, my scale factor would be bigger than 1, which is why they were all 6, right? Bigger than 1. So it doesn't matter which one you do as long as you're consistent through the whole problem. All right, last example. Why don't you do it first? Tell me what you think. Are these two triangles similar? And if so, how do you know? All right, we finally got one that's not similar. So I'm going to take, this one I'm going to go the left side over the right side. So longest side is 16, shortest side was 4. So the scale factor to go from the smaller to the large was a scale factor of 4. If I take my medium side, 10 over 3, that's 3.33. What do you notice about those scale factors? They're different. So are these sides proportionate? Nope. I can double check the last one even though I already know my answer. I get 8 divided by 2 is 4. So we could say the green side and the red side were proportionate, but the blue side was not proportionate. So if all three are not in the same proportion, these are not similar. All right. So kind of like when we did congruence, we've got those different postulates to remember. This time we have angle, angle, side, angle, side, 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 side. The difference is the sides now need to be proportionate instead of congruent. We're going to use this idea to start solving some problems and eventually do some real life problems with indirect measurement. So fun things to look forward to. Have a great rest of your day. Go Titans.